The dope sheet is like a more powerful version of the timeline when it comes to keyframe editing. I believe that the dope sheet is the most important tool for animation in Blender, and that most of the animation editing you typically need to do can be done through the dope sheet alone. But what is the dope sheet? Well, the dope sheet is a keyframe manipulation tool that you can use to drag keyframes, scale them, retime them, delete them, etc. So let's see how to use it. To access the dope sheet, you can technically create a new panel in your current workspace by right-clicking, selecting Split Area, and left-clicking to confirm. Then selecting the dope sheet editor from the editor drop-down menu. Alternatively, however, we can simply go to the animation workspace, and the dope sheet will be provided for you at the bottom instead of the timeline. This is what we'll be using. As you already know from the timeline video, Blender lets you select and transform keyframes in various ways. These methods of keyframe manipulation all work in the dope sheet as well: selecting, deleting, moving, scaling, etc. Additional keyframe selection options also exist under the Select menu. Let's go ahead and make some keyframes for our object so we can see what this looks like. Just like our timeline video, let's once again animate a simple bouncing ball. But this time, let's use the ball rig that we have included in this course, so we can also apply how to use pose mode. To import the ball character rig, let's simply go to File, Append, then navigate to our Assets Blend file, go to Collection, and select Ball Rig. Once in our scene, we can select our ball's armature object and go to Pose mode, then turn on Auto Keyframe. To deform the ball, we'll select the main ball bone and start transforming to set keyframes. We'll set a keyframe for a high pose on the first frame, go to frame 10 to set a low pose where it's touching the grid, set a much lower high pose on frame 15, and duplicate frame 10 to frame 20 for our final low pose. This is all very similar to our timeline video exercise. Excellent. Now we can go ahead and change our handle type for our extreme low poses on frame 10 and 20. This will once again give us that bouncing ball look. We can also bring our end frame back to 40 for a shorter playback loop time. Now, let's pay attention to our keyframes here. Unlike the timeline, our dope sheet provides a little bit more visual information about our keyframes. For example, each of these keyframes is a different shape based on the handle type. By default, in fact, our keyframes are no longer diamond, but rather round circles. Circle means the handle type is auto-clamped, which is the default ease in, ease out, while square means vector. Feel free to test what shapes the other handle types are. Additionally, you can also change the interpolation mode of your keyframes by pressing T or selecting one under the right-click context menu. When would you want to do this? Well, one of the most common interpolation modes, besides the default Bezier mode, is the constant interpolation mode. This is used most often for blocking an animation, turning off interpolation entirely so you can focus on your keyframes. We'll go over the process of blocking once we begin animating for our parkour scene later. But one thing you may have noticed is that we have far more keyframes here vertically than we did for the timeline. This is because the dope sheet separates and displays the different parent keyframes that can be expanded, giving us individual control over things such as the X location or Z rotation of an object. Keep in mind that selecting and transforming the parent keyframe will select and or transform all keyframes that belong to that group. Quick tip: to select all keyframes in a single column from any row, you can hold Alt and left click. Now, the channels we see here are determined by what object we have selected. But what if we wanted to see every keyframe in our scene from every object? To do that, we can simply change the settings here, which determines what keyframes to display. By default, this arrow icon is enabled, meaning that the dope sheet will only display keyframes of the objects you have selected. However, we can also toggle this off, allowing the dope sheet to display all keyframes of all currently visible objects. To also include hidden objects, simply toggle on the middle option with the dotted line cube icon. This will include any objects in collections that are currently hidden. However, it does not include objects in collections that have been unchecked. In case you ever get lost in the sea of keyframes or really need to zoom out quickly to see all of your keyframes, simply hover over the dope sheet and press Home. You can also go to View View All. Now, let's talk about a few more advanced dope sheet features that will be able to help us for our animation workflow. For starters, the View menu will give us several different functions and tools. The Show Sliders option is a great one that displays the values of each keyframe as a slider that you can adjust and animate very easily, all in one place. Without this turned on, you would need to go to wherever each channel is displayed, anywhere in the UI, to change its value directly. This also removes the need to go into the graph editor for every small adjustment, but we'll talk about the graph editor in another video. The Show Curve Extremes option also allows you to very quickly see the direction the motion of the curve is turning when it changes direction. For example, with our Y location channel, you can see based on these new icons that our curve is bending downwards for these frames and bending back upwards for these frames. If the curve is straight or simply exists between two curve extremes, it will not be marked as a curve extreme. But you might be wondering, what is a curve, and why do we keep talking about it when we're only looking at dots and straight lines here? That's a great question. The curves we're referring to are the interpolation curves that can be seen and edited directly in the graph editor. You can actually very easily enter the graph editor from the dope sheet by going to View, Toggle Graph Editor. Hotkey users can press Ctrl-Tab while hovering over the dope sheet to toggle between the graph editor and the dope sheet at any time. In the graph editor, you'll be able to see the curves clearly, showing exactly how the interpolation modes look and what curve extremes look like. In some software, the graph editor takes dominance as the keyframe manipulator, even basic keyframe manipulation, due to the absence of a powerful dope sheet. However, in Blender, with the dope sheet that it has, much of the basic keyframe manipulation can be done very easily without sifting through complex curves. But the graph editor can be very helpful for advanced tweaking and visualization. Compared to the dope sheet, the graph editor can do many of the same things, but also allows the user to view and edit the motion curves directly. Let me show you what I mean. I'll assume that you've already followed the instructions for animating the ball rig in the previous dope sheet video, which will give us some keyframes to test things out with. That being said, let's go ahead and go into our graph editor. In case you missed it earlier, you can easily toggle between the graph editor and the dope sheet by pressing Ctrl-Tab while hovering over the dope sheet. You may have noticed by now that our keyframes in the graph editor are represented by orange handles along the curves we see displayed. Another thing you may have noticed is that the handles are different for the frames where we had to set the handle type to vector, where the ball touches the ground. To show this more clearly, let's go ahead and set the handles back to their default handle types. We can do this very quickly by selecting all the handles in the graph editor with the A hotkey and then pressing V Auto Clamped. Now that we've done that, let's try to set those handles back to vector using only the graph editor. First, let's locate again the frames that we want to set the handles to vector for that bouncy feel. This should be frames 10 and 20. However, selecting these keyframes becomes a bit difficult, since each handle represents a separate channel of a keyframe. If we want to select all handles on a single keyframe, we'll want to hold Alt before clicking the handle we want. This acts similarly to selecting a column of keyframes in the dope sheet. So for this, we'll go ahead and Alt-click any handle on frame 10, and Shift-Alt-click any handle on frame 20. Then we'll press V, Vector. As you can see, the handles have changed visually this time, accurately showing how the animation will be interpolated. Unlike the dope sheet and timeline, the graph editor directly shows you what changing the handle type looks like in terms of the interpolation curves. We can then play our animation with spacebar to confirm that we did it right. Now, let's observe our graph editor a little more closely to see how similar and how different it is from the dope sheet. Before we move on, I want to say that in case your graph editor is too zoomed in or you can't see all of your keyframes, simply hover over the graph editor and press Home. You can also go to View, View All. The first similarity we'll notice is the left-hand column. Just like the dope sheet, the keyframes have all been assigned to specific channels. You can expand and collapse channels by clicking the arrow or using the plus or minus keys on the number pad while hovering over the channels. However, you might notice that while the channels are listed, there are no rows of keyframes to see which keyframes belong to which channels. In fact, our keyframes have all been transformed into curves, so what do keyframes even look like in the graph editor? Well, keyframes are indicated by the orange handles we've already talked about. You can see them spread out along the curves. And each curve belongs to a channel. To show this, simply left-click any of the channels on the left to highlight the corresponding curve in the graph. To isolate a curve, you can left-click to select it, go to the Channel menu, and select Hide Unselected Curves. For hotkey users, you can press Shift-H. This will hide all other curves for you. To unhide all the curves, simply go back into the Channel menu and select Reveal Curves. For hotkey users, you can press Alt-H. Now, let's go ahead and isolate only the location curves, and try to manipulate our keyframes and curves using the graph editor. As you can see, each of the keyframes in each channel exists on their respective curves as these orange handles, which we can select and transform using the same selection and transformation options we typically have in Blender. I'm going to simply shift left-click a few of these keyframes and start using G, S, and R to transform them. As you can see, moving, rotating, and scaling keyframes are all possible in the graph editor, allowing for very versatile and intuitive transformation of the curves. But what if we select a single handle? Each handle by itself is technically made up of 3 selectable parts: the main body and the 2 handlebars. By default, the endpoints of each handlebar can be transformed as a way to rotate the handle and manipulate the length of the handles, which affect how the curve interpolates between keyframes. You can also select the body and use R or S to rotate or scale both handlebars simultaneously. However, handle transformation differs depending on what handle type we use. For example, the vector handle types we have at the extreme low poses for our ball can be edited individually on each side. It also can't be rotated, as vector handle types must point to the previous and next keyframes. Quick note, when you break an individual handlebar off of its default orientation of auto-clamped by rotating it or dragging it, it will convert the keyframe handle type to aligned. Aligned is when both handlebars are moving together, whereas free is where each handlebar moves independently. Feel free to experiment with other handle types. Another thing we talked about is the interpolation modes. Interpolation modes can also be very easily changed in the dope sheet and timeline, but we never talked about what they look like in the graph editor. Since the graph editor is composed specifically of interpolated curves, the interpolation mode greatly affects how the interpolated curves look. Let's try a few by isolating the Z location curve and selecting all the keyframes by pressing A. We can then go to the keyframe menu, go to interpolation mode, and select constant. As you can see, the constant interpolation mode removes all curve interpolation and simply repeats the previous keyframe's value until it encounters another keyframe. If this looks like a familiar pattern to you, it might be because you saw it in the interpolation mode menu for constant. As you can see, each of the interpolation modes has an icon that represents what the curves look like when in that mode. Feel free to test out these modes to better understand them. Bezier, however, is the default, and we'll be changing ours back to Bezier for now. Now that we've gotten basic curve manipulation out of the way, let's talk about more advanced curve manipulation options, specifically curve modifiers. Curve modifiers are extremely powerful, non-destructive functions that can help you alter and adjust your curves. There are a few, but to demonstrate this, I'm going to show you how to use the noise curve modifier. To add curve modifiers, simply open the right-hand side menu in the graph editor. You can do this by clicking the arrow icon on the right or pressing N. From this right-hand side menu, go to the Modifiers tab. Make sure you have the curve you want to modify selected. We'll go ahead and select our Z location curve by clicking on the Z location channel on the left-hand side. Then we can go into the Add Modifier drop-down menu and select Noise. For hotkey users, you can hover over the graph editor and press Ctrl-Shift-M and select Noise from that menu. Immediately, you can see how the noise modifier affects our curve, as the curve now has a noise pattern added all throughout it. If we play our animation back, we can see that a slight shaking effect has now been added on top of our original animation. Even if we set new keyframes or move them around, the shaking effect adjusts to the curve dynamically. Just like mesh modifiers, we can also adjust the modifier settings to change how the modifier affects our curve. Feel free to experiment with each modifier's settings to understand them better. But these two options at the bottom are important to try as well. If we expand the restrict frame range option, we can see a start and end range that we can set. This will allow us to restrict the effect of the modifier to specific frames along our curve. Additionally, the in and out frames will allow us to fade the modifier influence in or out a certain number of frames. For example, if I set the fade in value to 10, the curve modifier will slowly fade the influence of the effect over the course of 10 frames. Furthermore, you can also manually adjust the influence slider below that under Use Influence. Collapsing either of these options will also disable them. In the graph editor, wrench icons represent curve modifiers, but the only time you see this icon is next to the channel names. That's because this wrench icon is used to toggle on and off curve modifiers for that specific curve for your convenience. Similarly, the checkbox disables the curve's value from affecting the object at all, and the lock icon prevents changes to be made on that curve. I hope this video helped explain what the graph editor can do, what curves are, and how you can use the F-curve modifiers to help you animate.